So today we are going to graph the inverse functions of cosine, sine, and tangent. And in order to do that, we first of all need to review a little bit about the regular cosine graph, the regular sine graph, and the regular tangent graph. So this very first example, I have the graph of cosine, and just what you're used to, starting at the max and its normal period. The domain of it is negative infinity to infinity because it goes on forever left and forever right. The range is from -1 to 1 because the max is 1 and the minimum is -1. Now, if we're going to do the inverse, we first of all need to make this a function. A 1-to-1 function. If you notice, this is a function, but it would only pass the vertical line test. It would not pass the horizontal line test. So its inverse would not be a function. So the first thing I need to do is graph my cosine graph just between 0 and pi in its principal value. This C is uppercased. You don't see that as often anymore, but the uppercase C means to restrict it just to its principal value. So that's from 0 to pi. The range does not change. It's still from -1 to 1. So I'm going to graph just the regular cosine graph restricted with its principal value. So from -1 to 1, and then the domain is from 0 to pi. I'm going to make 2 over pi over 2, and then 2 more pi. So at 0, we have a point at 1. At pi over 2, we have a point at 0. And at pi, we have a point at -1. So that's the cosine graph restricted to just its principal values. So now what we're going to do is graph the inverse. Remember the inverse, you just switch your x and y values. So what that's going to do actually is make your domain your range and your range your domain. So just switch your domain and range. Your domain becomes -1 to 1 and your range becomes 0 to pi. And now I'm going to graph it. So your y-axis, now you want to go up 2 to make pi over 2 and up 2 more to make pi. On your x-axis, go 2 to the right to make 1 and 2 to the left to make -1. And then you have the points here. Here you have the point 0, 1. So over here you want to plot the point 1, 0. You're just switching the x and y. Here on the regular graph, the point is pi over 2, 0. So on our inverse graph, we're going to graph the point 0, pi over 2. And then here we had the point pi, -1. So we're going to graph the point -1 pi. And then you just connect it just like it was before, but now it's the inverse. So that's the inverse function of cosine of x. So now let's do sine. Here is your regular sine graph. The domain and range is going to be the same as it was for the cosine graph. The domain is all real numbers, so from -infinity to infinity. The range is from -1 to 1. Again, we are going to restrict this and draw it with the capital S so that it only has the domain and its principal values so that its inverse will exist. It has to be 1 to 1 to be able to have an inverse. So the domain is going to be from -pi over 2 to pi over 2. That's our principal values for sine. And your range will still be from -1 to 1. And so we know that sine starts at the SA and goes up. And so these are the main values we're going to graph. So when we write the domain is -pi over 2 to pi over 2. Notice it has square brackets because those are included, and -1 to 1. So now when I do my inverse, I'm going to switch. My range becomes my domain, and my domain becomes my range. So my domain is -1 to 1. My range is -pi over 2 to pi over 2. And then I'm just going to graph my inverse points. So your x-axis, you want to do -1 to 1. Your y-axis goes from -pi over 2 to pi over 2. Notice here I have the point -pi over 2, -1. To switch that, it's going to become -1 to -pi over 2. Here's 0, 0. The inverse of 0, 0 is also 0, 0. And here we have pi over 2, 1 just becomes 1 pi over 2. It looks very similar, just the concavity is different. If you're ever unsure, you could always test some more points. Like you could test pi over 4 and see which way it goes in. Okay, lastly, we have tangent. Tangent's graph, remember, has asymptotes at -pi over 2, pi over 2, and then the period is pi. So all of its asymptotes appear pi away from each other. So the domain it goes on forever left and forever right, but it has all these undefined values. So to say the domain, you could say it many different ways, but one way is to say all real numbers except x cannot equal negative pi over 2 plus pi n. Now, that could also be said as positive pi over 2 plus pi n. This n stands for an integer. So you could be plugging in 0, 1, 2, -1, -2. It's just showing you that's how often it occurs as you add or subtract pi to negative pi over 2. Now, the range is just going to be negative infinity to infinity because it goes on forever up and forever down. Now, again, we have to restrict it so that it's a one-to-one function. So we're going to restrict it from negative pi over 2 to pi over 2. Notice how on tangent I use parentheses instead of brackets because it's never going to equal pi over 2 or negative pi over 2 for tangent. The range we're also going to use parentheses because it goes on forever up and forever down, negative infinity to infinity. So now when we restrict it, we're just going to have to do 2 to the right is pi over 2, 2 to the left is negative pi over 2, 2 up is 1, 2 down is -1. And you're going to go ahead and draw on those asymptotes at negative pi over 2 and pi over 2. Here I have drawn in the points for pi over 4. Remember that the period of tangent is pi, but there's also critical points at pi over 4. And since the period is pi, the distance between critical points is pi over 4. So at pi over 4, remember the tangent of pi over 4 is 1. The tangent of negative pi over 4 is -1. So those are important points. And then the asymptotes are at pi over 2 and negative pi over 2. And then you just draw your basic curve for tangent, just showing one period with the principal values. That's a really bad drawing, sorry. And now we're going to do the inverse. So inverse, again, we switch x and y. So the domain becomes the range becomes the domain. So this time the domain is going to go on forever left and forever right. The range is going to go from negative pi over 2 to pi over 2. And remember those 1 and -1 values happen still at pi over 4. So I'm going to go and draw in the asymptotes. This time they're going to be horizontal asymptotes instead of vertical. And then when we draw in our inverse points, just switch x and y. And now it's just the tangent curve on its side.